So, CO2 laser build. So we got our tube built, we've got it working, we got an output, finally. So now I want to make a box to house everything that is involved in making this thing work. So I've done some testing. This 40 kilovolt laser power supply that I got on Amazon will work to run the current tube. And if we want to make a better tube that can harness this amount of power, we've got the power. So we are going to use this. Now it'd be nice to run it off of the neon sign supply and rectify it and all that fun jazz, just to get a high voltage capacitor that's not from a microwave, a higher power neon sign transformer, all that. We're looking at upwards of $500. Well, this power supply was 100 off of Amazon, so sorry if that's lame. I wanted to use a fridge compressor for the vacuum pump. That ain't gonna happen. I need to have two paralleled, and if I have two parallel vacuum pumps, I might as well just have the one Harbor Freight vacuum pump. So we're gonna stick with that. And as for the cooling system, I found this old AC unit at the scrapyard with a 24 volt DC fan, and this thing looks pretty substantial. I think we can just get the radiator out of this and use that as our cooling system. Now then, I work a whole lot better being able to kind of see the space that I have. So we're going to start out by building the case, and then we will figure out how all the different components are going to work after the case is roughly built. The only way to get through this is a montage. So we got our box. It took me a little bit of finagling to figure out how to get the sliding to work, but we have full access to everything inside. So this top part will slide off, and then once that's off, we can pull the front off. So now we just fill the box with all the good stuff. For the coolant system, we're gonna use the same little pond pump that I've been using, but we're gonna make it so that it's affixed to a plate so it'll be easy to change if I find that it doesn't work good enough. And to make the tank, we're gonna make it out of aluminum, because as you know, aluminum oxidizes very quickly, and I'm hoping that oxide layer will make it less likely for particles to come off of the aluminum into the solution and make the distilled water more conductive. So, let's cut some aluminum. Now then, let's get these welded together. Man, is there anything worse than having to wipe down pieces of aluminum before welding? Like, to weld aluminum, you really gotta want it. Ta-da! So this is gonna be our tank. It's 5.5 by 4 by 13, and I did the math, and that's plenty. That will hold twice as much volume as we need to fill the tube and 100 feet of hose, which I'm not even gonna be using 100 feet of hose. So we're good there. Now we gotta make our plate that will hold all the fittings for the pump. I hate to do this because this piece is really nice, but this is the only solid stock of aluminum that I have that is big enough for a 1/4 inch thread. So I'm sorry, little buddy. Look at those chips. I can make an aluminum scarecrow. So you can probably see where I'm going here. This will be tapped to 1-inch NPT. These will be 1/4-inch NPT. And I will cut a hole in the top of the tank that this will sit over with a gasket. And this will be our inlet and outlet port, and this will just be for filling. We gotta use this big honker. I never thought I'd have the day where I need a bigger tap wrench. I don't know if I've ever ran out of breath from tapping a hole, but that was rough. But we're good to go now. I'm gonna fill this thing up with water and see if there's any leaks. So I filled it up, spun it around and inspected it and found these little pinholes, which honestly is not that bad. Although this one seems to be underneath the plate, which is that bad. We'll see what we can do about them. So, how is this pump going to be attached? As you can see, this pump has a stupid little slip fitting, which makes this whole thing a pain in the butt. Well, this slip fitting does have a barbed fitting that goes into it. I don't want to have any barbed fittings inside the tank because that would mean a steel hose clamp inside the tank. So, this is the smallest nylon thing I could find. I'm gonna machine it down to where it fits inside of here. Then we have some 1/2-inch male threads that we can tie onto with everything else. Bloop. Alright, let's get that epoxied in place. And while that sets up, we can find a nice spot in the box to mount our tank. So to mount this thing in here, I've got these bolts in here. Just gonna weld them in place. I want to have as few bolts going through the bottom of this as possible. So here's my latest plan to get the fill up port on the outside. I'm gonna use this fitting as sort of a funnel, so that will be the outside with a 1-inch nipple threaded into the back end. And then I'll have part of a nipple threaded into here, and I'm going to cut and machine this nipple to act as somewhat of a barbed fitting on this big piece of vinyl. It's going to be quite the squeeze to try and get this to work, but it's kind of the best option I have. We got our little bell reducer with our makeshift barb on there. Now I need to cut a hole in here for this to fit in. Got my fill up attached to the case. Now I'm kind of thinking I want to get all the welding galvanized stuff done with. So that way, if I'm gonna get sick and spend the rest of the day in the bathroom, it'll only be one day. I went ahead and cut out a vent cover on the plasma cutter off camera. I'm sure you guys are sick of seeing that plasma cutter. And just another hole here for the sight glass for the vacuum pump oil. Anyway, let's get this thing installed. Yeah, I don't think that's gonna work. Dang. Problem solved. Well, as you can see, I found the proper hose for the fill up. It's gonna be pretty painful to fill this thing up, but we can fill it up now, so that's good. Now then, the pump attaches to this plate like so, with a rigid nipple here to keep it all the way at the bottom. And I have this very professionally made gasket, and the pump will just drop in here like so. And now we can just put some barb connectors on here for the outlet and the inlet. Now then, start working on the radiator. So to get this radiator to work for our purposes, I've snipped these down short, cleaned them up with emery cloth, taken a 3/8 barb splicer and cut it in half. Now, I'm gonna slip these on here and sweat them on. I got this little hose fitting. I'm gonna go and flush this whole thing out because there's probably some residual Freon and whatever else was in here and there. I really don't want to do this in my backyard. Is the neighbor home? So our fittings are sweat on. I've cleaned it up a little bit, stuck some bolts in the holes. Now we mount it. Ding. outlet of our pump is going to go to the outlet of the case. The inlet of the case is going to go to the inlet of the radiator, and then the outlet of the radiator will go to the inlet of the tank. And that's about it for the plumbing. So it comes out of pump to laser, from the laser through the radiator, back into the tank. That's the water system done. Now we can start working on the gas. So first things first, we got to mount the vacuum pump. We're keeping the rubber feet on there, hopefully to reduce vibrations. And we just got to line the oil sight hole up with this guy. I hate to say it, but the best way I got to install this vacuum pump is to take all of this out. So I'll see you in an hour. Alright, so we still want to be able to control our needle valve. I don't want to have to run needle valves up to the front of the machine, and I don't want to have to open the case. So I've 3D printed these parts. This will hold the needle valve in place, and then I have this part, which is going to be press fit onto the top of the needle valve and press fit onto this little servo thingy. And then we just attach our servo to this guy, and we can control the needle valves with an Arduino. It'll look just like that. Now, I did not print a structure to hold the servos because I figured it'd be easier and stronger to make them out of steel. So let's start building this unit. Now, I think my personal hell would just be endless stick of steel with endless holes that need to be tapped. I'm pretty happy that these servos have so many mounting holes. 4 holes means I can mess 2 of them up. But 4 holes per servo also means 8 chances to break this teeny tiny little tap. Now to search around the floor for some number 6 screws. I couldn't find them on the floor. I had to go find them at the Home Depot. Beautiful! Now then, we can press these guys into here. I think that's it. Huh? So I've built these valve bodies, we'll call them. There's a needle valve with our little servo attachment on the top and a solenoid valve on the other side. That way when the system is off, everything will be cut off. And one of them has it on the inlet for the gas, and the other one has it on the outlet for the vacuum. So now, the camera died, which was an excellent opportunity to epoxy these in place. And when I was doing that, I noticed that this needle valve is different from this one. So this one is just shimmed with 2 popsicle sticks at the bottom. It works, right? Now, we just gotta tack this in place, cut off the excess, and then mount it in the case. So I've mocked it up with my 2 power supplies, and this is kind of the best spot for it. We're starting to get a little bit cramped in here. I think I gotta run to the store and ravage their 1/4-inch plumbing fittings again. Cause one, I gotta get some street elbows to come out of these needle valves, cause there's no way I can bend the tubing to where it won't interfere with the case. And 2, I kinda wanna do a rigid pipe section up to here and have a vacuum gauge sticking out of the wall here. So I'll be back with those parts. So I've gone ahead and done just that. I got 2 street elbows to get these out of the way of the cover. And then I got rigid pipe all the way up to a vacuum gauge. And then this will go to the vacuum pump. Man, that's as close to perfect as I'll ever get. That is beautiful. And now for the plumbing. So this one goes to the vacuum pump, and the other side of it will go to the inlet port. This solenoid valve will go to the gas inlet that'll come off of the tank. And I forgot a dang hose clamp. And then the other side of it goes to the outlet that goes to the laser. Man, this thing could really use some cable management. Okay, it's not that much better, but it's a little better. Now then, moving right along the case is this PC power supply. I'll be using this to control all the small electronics and the fans. Now, very conveniently, dang thing doesn't have any mounting holes on the bottom. It's just got these little, like, clips. I don't really like that. Either way, I think I'm gonna jam it in right there. So I'm thinking to mount the power supply, we're gonna do just like a clampy bit kind of thing. So, got this all marked out. It's gonna be drill, drill, bend, 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 cut. Beautiful. I'm gonna attach these bolts just the same as the rest of them. And now, the final piece of the puzzle, the laser power supply, which barely fits. So I'm gonna drill some holes here for the wires to pass through, and I'm just gonna cross my little fingies that I'm gonna have enough clearance for this front cover. I can't quite describe how wrong this feels. Yeah, we don't gotta talk about that. Hopefully 2 mounting points is plenty for that power supply. If not, I'll figure something else out. Now, the next couple things that I need done, I'm gonna have an extra shelf up top here, and then I want a fan that will pull air into the case. So, I think I'll make the fan plate first, and then the shelf. Got me a plate that'll fit these 2 fans. Now I just gotta cut a hole in the enclosure and install it. So I got my fans installed on the plate, and we're gonna install this fan plate in our totally tried and true, very professional method. Self-tappers. Beautiful. So we're nearing the end of this case. The last thing we're gonna need, I need to install an upper shelf here that can house all the CNC control things, the Arduino, whatever I'm gonna use to control it. So, let's get that built. Man, I was in such a hurry to put this thing up. I didn't realize that this is shorter than the distance I need over here. So, it's a little out of square. The real question is, how much does that bother me? Evidently, not enough to do something about it. So it appears we're reaching the end of this project. All we gotta do is mount the Arduino, drill a couple holes in the case, mount a few relays, and then we get to that glorious part where I paint the thing and do the electronics off camera, and we can do our grand unveiling. Ta-da! It's now much more of a mess than when we started. I don't know if the wiring for this really warrants an animation. It's very simple despite the, apparent mess. But basically, I've got a bunch of relays that control all of the AC switching. One for the vacuum pump, one for the pond pump. One turns on the laser power supply. This last one's just an extra. I thought I needed another. All the Arduino is doing is sending a high signal to the laser power supply when I flip a switch. That way I can turn the laser on and off using it. Also reading these 2 pots and writing that signal to these servos, which is honestly the coolest part of this whole build, in my opinion. Now, this pot with scribbles on the back is kind of messed up and spits out inconsistent signals. So, one of these, very sporadic. The other one works wonderfully. I will be getting a working pot for this servo, but for now it's just hooked up to the vacuum side, which is not as critical, to be precise, as the input side. So that's all fine and dandy. As of right now, the output of the laser power supply is controlled by the Arduino, but just by reading a switch. So that works just fine. One opens our solenoid valves, one turns on the pond pump, and one starts the vacuum pump. So that all seems to work pretty good. Let's put the case on and give it a whack. Ta-da! Yeah, I got a vinyl cutter. So I got the case put back on. I've hooked it up to the laser. I was gonna build a nicer mount for the laser itself using these 3D printed parts, but after building this huge box, I'm not exactly sure how it's going to fit onto the final CNC machine yet, so I figure save these parts for later and have this box as its own separate unit for now. Now, these switches and pots are all very clumped together, but as I said earlier, in the future these will be replaced with aviation connectors, and the control panel will be on the front of the CNC machine. But man, I think it looks pretty cool if I don't say so myself. So, now all that's left to do is to run the laser on it. First thing we do, hook up the gas to this convenient little quick connect. Laser goggles on. This switch starts the power supply and the fans. You can hear the fans running in there. This switch opens the solenoid valves for the gas and the vacuum pump. This starts the cooling system, which honestly you can't even really tell if it's running besides the couple trickles of bubbles that flow through the pipe. This turns on the vacuum pump. These are our two pots for controlling the needle valves inside. We're gonna leave those barely cracked. And then, so that discharge looks a little dark, gotta open our valve a little bit. There we go! That's nice. I haven't adjusted those mirrors in a long time. And just as easy as we turn it on, we can turn it all off. Beautiful. Yeah, man. I am very pleased with how this turned out, both aesthetically and on the inside, which is what counts. So this control unit is going to be our first step in building the CNC machine, just basically getting everything to get the laser working enclosed in a box. And you know, initially I thought I was just going to build the CNC machine off of this and have the tube sitting up top here, but I'm kind of thinking the whole thing is a little bit modular now since I'm going to install some plugs on here, so I can have this wherever I want, which I guess that means I'm back to square one for designing the CNC machine, but that's all problems for the future. But either way, this project's putting right along. Remember to leave a good old dinger. Think about subscribing, and thank you so much for watching.